Hello. So we are planning to teach remotely from now on until foreseeable future in the next term at least. And I thought that this is an opportunity to document and record little tangents that I make during the lectures. I've had some feedback from students in a couple of courses that those are helpful in retaining the information, hopefully transforming it to knowledge. And one of the first thing I wanted to talk about is something that we often mention in the introductory lectures in the fluid mechanics courses, for example. It's the concept of first principles. So this talking about thinking from first principles. This concept has become very popular in recent years or months, popularized by exceptionally bright people like Elon Musk, and you can read Tim Urban's blog about all this concept of first principle thinking. It's a wonderful concept, but I wanted to mention an even more illustrious figure than Elon Musk. It's the forefather of the scientific method and the principle itself. It's Sir Isaac Newton. So the motivation for that is that we, in fluid mechanics, one of the first or one of the most challenging equations that we deal with throughout the entire course, and actually more than one course, is so-called Navier-Stokes equation. And that is nothing more than the conservation of momentum, which is a fundamental principle of mechanics. And that is itself a formulation for that is the Newton's second law, which is F equals ma. The force is proportionate to acceleration, and the proportionality coefficient is the mass of the body. And we, to derive the Navier-Stokes equation, we apply that conservation of momentum principle to an element of the fluid, collection of fluid particles. And we make few assumptions along the way. One is the continuity assumption, so the fluid particles are in constant contact with each other, they always interact. There is also assumption of a Newtonian fluid, and this is where the shear stress applied to a fluid element is proportionate to the strain rate. Things like that lead to this formulation, which is famous, Navier-Stokes equation. Everything else that we encounter in terms of specific applications, so specific equations that describe particular applications to engineering or nature, such as pipe flows, boundary layers, etc., are just special cases of Navier-Stokes equations from that point. They're just additional assumptions that we make to discard some of the terms and make the mathematical model, the equation, more tractable or approachable by analytical methods, pen and paper, or computational methods, CFD, computational fluid dynamics. Idea itself, the first principle is that the force is proportional to acceleration, force acting on the body. This was laid out famously by Newton, and it's an example. So this is all motivation, but the tangent is actually these books. There are a couple of volumes called Principia. A colleague of mine was cleaning his office and giving away some books he had, and I couldn't resist picking those out. And they've been sitting on my shelf, and I was reading them as a kind of distraction from real work that all of us have to do, but just enjoying the language and how they're written, and actually how profound the ideas were. This work, incidentally, this work was written in 1665, 1667. It was actually, the first edition was published in 1686. But during that time there was a bubonic plague in Europe, the largest outbreak of plague in England since 1348 Black Death, and many people escaped from the city. So 15% of London population died, and Newton felt threatened in his urban dwellings, and he went to countryside, the Woolthorpe, for a couple of years, and that was a very productive time for him. So he felt that college life regiment was too stringent and not conducive to creative scientific work, according to his own records. But he really made some fantastic advances in optics, in the theory of gravity, etc. at that time. So this is kind of ironic, and I think is a good example to these days when we are teaching remotely, we're in isolation, social distancing, and the work of Newton, for example, the fundamental work on which we base all our research and teaching is created. It was created also during this quarantine period. There are some stories of heroic quarantine by the villages, the outskirts of London, that put themselves on quarantine to stop the spread of the disease and so forth. But I think what's inspiring is seeing how one can make good use of the circumstances and apply one's mind creatively, and just, I mean, of course, Newton was a genius, but how much can be done even in the conditions of isolation and drastic change to a lifestyle. So just to give you an example of the type of things he was describing in the Principia, I'm going to read one passage, and this is very beginning of the first volume, page 3. It's a definition of a centripetal force. The example of that would be gravity, by which bodies tend to the center of the earth. And he writes, for example, if a leaden ball projected from the top of a mountain by the force of gunpowder with a given velocity and in a direction parallel to the horizon is carried in a curved line to the distance of 2 miles before it falls to the ground, the same if the resistance of the air was taken away, with the double or decupled velocity would fly twice or 10 times as far. And by increasing the velocity we may at pleasure increase the distance to which it might be projected, and diminish the curvature of the line with which it might describe, till at last it should fall at the distance of 10, 30, 90 degrees, or even might to go quite round the whole earth before it falls. Or lastly, so that it might never fall to the earth, but go forwards into the celestial spaces and proceed in its motion in infinitum. So this is 17th century, just to remind you. So quite a leap of imagination and conviction in scientific methods. So that is first principles, and that's an example of how much can be accomplished in the worst circumstances of the present moment and kind of the current situation in the world by applying one's mind and creativity fully. That was inspiring to me, so hopefully you find it amusing, and I'll see you next time. Thank you.